Determine whether the given infinite series is convergent or divergent. In the case of convergence, specify if it's absolute or conditional. Justify your answers. That means write sentences and reference the test you're using. All right, so for this first one, I have -1 to the n times 3n plus 2. That -1 to the n tells me that the signs are alternating. Okay, and then this second term here, 3n plus 2 over n cubed plus 3, because the numerator degree is less than the denominator's degree, I know that those the values of that are going to approach 0. Decreasing to 0. So the alternating signs test tells me that this is going to converge. Since the terms are decreasing towards 0, the series converges by the alternating series test. Then we have to check for absolute convergence. So I want to look at the sum without the alternating signs, just positive terms. So I'm looking at 3n plus 2 over n cubed plus 3. I'm going to use the limit comparison test by comparing to 1 over n squared. Okay. I'm going to take the limit as n goes to infinity of 3n plus 2 over n cubed plus 3, my generic term from the series, and compare it to a comparison series 1 over n squared. I picked 1 over n squared to compare to because I know whether it converges or diverges. I know that the sum of 1 over n squared converges. So if after I take this limit, if I get a finite non-zero number, I know that my series does the same thing as my comparison series does, which is converge. So I just have to finish calculating this limit. So I have 3n plus 2 over n cubed plus 3 times n squared over 1. So this is going to be 3n cubed plus 2n squared over n cubed plus 3. Now I have a rational expression here. The degree on the numerator is the same as the degree on the denominator, which means the limit as n goes to infinity is the ratio of leading coefficients, 3 over 1. So this is 3. Because this comes out to a finite non-zero number, finite and non-zero number, that means that my series that I was curious about it has the same behavior as the comparison series 1 over n squared. Since I know 1 over n squared converges, so does my series. So that means I had convergence of the original series. I have convergence of its absolute value. That means I have absolute convergence for this one.